All right, we have a homework review 7.1 to 7.3. We're going to have a quiz over this. So the first thing we have up is a term, define ratio. That's a comparison of two quantities. Quantity is just a number. So anytime you compare two numbers in a fraction or with a colon or with the number TO2, that's a ratio. Define proportion. Well, that's when you take two ratios and set them equal to each other. Number 3, supposed to solve this proportion. So we could simplify the fraction on the right at the beginning if we wanted, and I believe I do want to. We can divide the top and bottom by 2 and get 4 over 15. Then I can multiply both sides by 12 to get x by itself. On the left, it's going to give me x, because the 12 divided by 12 is 1. On the right, we got 4 divided by 15 times 12. I can divide both 15 and 12 by 3. Goes 5 times into 15, goes 4 times into 12. I'm then left with 4 times 4 on the top and divided by 5 on the bottom. So x is 16/5. Number 4, I cannot reduce my fractions. So I'm going to go ahead and multiply both sides by the sum of 9 and x plus 2. Why did I choose 9 and x plus 2? Because on the right then, when I multiply and divide by the same thing, they cancel. On the left, when I multiply and divide by the same thing, they cancel. Now I don't have any fractions. On the left, I get 10 times the sum of x and 2. On the right, I get 30 times 9. If I distribute the 10 using the distributive property of equality for real numbers, I get 10x plus 20. On the right, multiply 30 times 9, I get 270. If I subtract 20 from both sides, I get 10x is 250. Thusly, x is 25. Number 3, scratch that. Number 5, the ratio of two measures of the angles, the ratios of the measures of the angles in a triangle is 3 to 5 to 7. So I don't know what these measures are, but I know the relationship between them. Like if they were 3, 5, and 7, that's cool, but that doesn't have to 180. So they could be double these numbers, or triple, or quadruple, or times 5, or times 6. We don't know how many times bigger the actual angles are, so we multiply them all by the same number. Then we use the angle sum theorem, which says when you sum up all the angles in a triangle, it equals 180 degrees every time. Summing the angles, we get 15x equals 180. If we divide both sides by 15, we get x is 12. That does not answer the question. What is the measure of each angle is the question. One of the angles is 3x. One of the angles is 5x, one of them is 7x. Since we now know x is 12, we're going to have 3 times 12, which is 36. We're going to have 5 times 12, which is 60. We're going to have 7 times 12, which is 84. This is not good enough for the answer because the question is, what's the measure of each angle? We should write this out as a sentence. The measures of the angles are 36 degrees, 60 degrees, and 84 degrees. Number 6. On a map of Ohio, 3/4 of an inch represents 15 miles. That is an example of a ratio. 3/4 of an inch on the map is 15 miles in real life. If it is approximately 10 inches from Sandusky to Cambridge on the map, so 10 inches on the map, what is the actual distance in miles? So we'll give that a variable such as x. Well, we need to solve this equation for x. I'm going to choose to simplify the left side first because it's a complex fraction. I'm going to multiply that fraction by 1 in the form of 4 over 4. 4 divided by 4 cancels. Now we have 3 over 60. Because 1 times 3 is 3, 4 times 15 is 60. I'm going to get rid of my labels now. You can leave them on if you want. Now I'm trying to get x by itself. Well, before I do that, I can cancel some more. I can divide both 60 and 3 by 3 and get 1/20th. Now if I multiply both sides by 20 and x, to get rid of my fractions, on the left the 20's cancel, on the right the x's cancel. So I end up getting x equals 200. What is the actual distance in miles? It is 200 miles from Sandusky to Cambridge. Flip it. Another definition. Define scale factor. That's the ratio of two corresponding sides of two similar polygons. You have to include the word corresponding. You have to include the word similar. Define similar polygons. Two polygons are similar if the corresponding angles are congruent and corresponding sides are proportional. Number 9. Determine if each pair of polygons is similar by using the definition of similar. Justify your answer. So we have to determine and we have to justify. So if you look at the angles, 50 is congruent to 50, 60 is congruent to 60, 70 is congruent to 70. So the corresponding angles are congruent. Now let's see if the corresponding sides are proportional. Now, fortunately for us, these triangles are drawn in the same orientation. Corresponding parts are in the same positions, is what I mean when I say that. So now let's compare. We think that these correspond, and these correspond, and these correspond. So 2 is to 3 should be the same as 1.6 is to 2.4, which should be the same as 1.8 is to 2.7. Are those all equal to each other? Actually, you know what? I'm sorry. I was going to say we could just say angle-angle similarity, but it says determine if they're similar by using the definition of similar. So we can't use the shortcut theorem of the angle-angle similarity. I was going to try to do that, but I just caught myself. I wouldn't be following the directions. So 2/3 is reduced already. 1.6 over 2.4, if I multiply the top and bottom by 10 to get rid of my decimal, I would get 16 over 24. If I want to get rid of my decimal in my other fraction, multiply it by 1 in the form of 10 over 10, I would get 18 over 27. And if I reduce those fractions, 16 and 24 I can divide by 8 and get 2/3. 18 over 27 I can divide by 9, top and the bottom, and I'm going to get 2 more thirds. So I got 6 thirds total. At this point we know they're similar by the definition of similarity. Corresponding angles are congruent, corresponding sides are proportional. The triangles are similar because corresponding angles are congruent and corresponding sides are proportional. Yay! Number 10. Same directions. Are these similar? Well, this has a 90-degree angle and this one doesn't. So we can stop right now and say the triangles are not similar because corresponding angles are not congruent. Number 11. If these two quadrilaterals are similar, find the scale factor, and it says quadrilateral PQRS 2, so PQRS goes on top, A, B, C, D. So I pick any side I want from PQRS, such as 11, make a ratio with it and its corresponding side, such as 33. This reduces to 1/3. because I can divide the top and bottom by 11. Scale factor is 1/3. Had someone else picked 5 and 15, that also reduces to 1/3. 18 and 54 reduces to 1/3. 7 and 21 reduces to 1/3. So no matter which pair of corresponding sides you pick, they all reduce to 1/3. 11, or a number from the first figure, has to go on top because it names that first in the scale factor sentence. State the angle-angle similarity. This similarity is a theorem. I know I didn't write that in the notes, and I wish that I would have, the word theorem. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Side-side-side similarity. If three sides of one triangle are proportional to three corresponding sides of another triangle, then the triangles are similar. Keywords. Side-angle-side similarity. If two sides of one triangle are proportional to two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. Number 5. In the figure, segment ST is parallel to segment PR. QS is 3, SP is 1. TR is 1.2. Find the length of QT. Well, we should probably first decide if these figures are actually similar. Angle Q is congruent to itself. That's because congruence of angles is reflexive. This angle and this angle are congruent because of the corresponding angles postulate. You get two parallel lines cut by a transversal. Similarly, which this is overkill at this point because we have enough information to say that they're similar, this angle and this angle are congruent because of the corresponding angles postulate. So I'm going to mark the lengths of these large sides. Then I'm going to redraw my pictures so they are separated. Actually, I'm not going to redraw them. The reason I'm not going to is the corresponding parts are in the same positions. So I'm focusing on this little triangle, and then I'm going to focus and compare that to this big triangle. No need to redraw it. So 3 is to 4, because 3 and 4 are corresponding, as QT is to QT plus 1.2. I just made a proportion using ratios of corresponding sides of similar polygons. Now if I want, I can't reduce either fraction, so I'm going to multiply both sides by the denominators. That's the multiplication property of equality. I can multiply both sides of an equation by anything I want as long as I do it to both sides. On the left, multiplying and divided by 4 cancel. On the right, multiplying and dividing by the same thing cancels. On the left, I'm left with 3 times QT plus 1.2. On the right, I got 4 times QT. Distributive property, I'm going to get 3 QT plus 3.6. If I subtract 3 QTs from both sides, I get 3.6 is 1 QT. Make sure I answered the question. Find QT. I've done that. Moving on. This one I'm going to definitely redraw. Let's first, before I put all the information in, are these pictures even similar? Well, there's a 90-degree angle and a 90-degree angle, according to a theorem that I don't know if we've actually talked about yet. It says that all right angles are congruent. So those are congruent to each other. And then this angle and this angle are vertical angles. Vertical angles are always congruent. I'm just going to go ahead and redraw this triangle. Be real careful when you do this. Angle that's 90 is S. Angle that has one arc is R. And the other angle that is not marked is T. Now taking from the directions, TS is 6. QP is 4. RS is x plus 1. QR is 3x minus 4. We're supposed to find the value of x. Since I have two similar triangles by the angle-angle similarity theorem, I can make a proportion 4 is to 6 as 3x minus 4 is to x plus 1. Once again, if you want to reduce your fraction at the beginning, you can. I'm going to reduce 4/6 to 2/3. If you choose not to do that, you're still going to get the same answer. To get rid of my fractions, I'm going to multiply both sides by 3 and x plus 1. I definitely want to get rid of the fractions on this because I have a variable in the denominator. On the left, multiplying and dividing by the same thing cancels. On the right, multiplying and dividing by the same thing cancels. So now we have 2 times the sum of x and 1 on the left, and 3 times the difference of 3x and 4 on the right. If I distribute the 2, I'm going to get 2x plus 2. If I distribute the 3, I'm going to get 9x minus 12. If I were to subtract 9x from both sides, I would get negative 7x plus 2 is negative 12. If I were to subtract 2 from both sides, I get negative 7x is negative 14. If I divide both sides by negative 7, I get x is 2. Let's just confirm that I answered the question. Find the value of x. I have done that, so I'm going to continue. 17. Jose performs a transformation on a triangle. The resulting is similar but not congruent to the original. Which transformation did Jose use? If the resulting transformation is similar but not congruent, it must be a dilation. So the answer is A. 18. A study reports that in 2000, the population of the United States was 282,054,422 people, and the land area was approximately 3,531,905 square miles. Based on the study, now if you pay attention to the question, you don't have to be able to math very well. You just have to be able to read. What was the population density? That's what the question is. And you might be thinking, I don't know what that is. But if you keep reading, it tells you exactly what that is. It says in people per square mile. Per means divided by. This problem is telling you to divide the number of people by the number of square miles. That is the population density. That is people per square mile. Round your answer to the nearest tenth. That's a detail we want to make sure we follow. This problem, if you just take your time and read it carefully, it answers itself. It's kind of like being JK. So the number of people is 282,054,422 people. The square miles is 3,531,905. For the love that's all that's good and holy in this world, do not do this by hand. Using a calculator, I got 79.9. The direction said tenth, that's 1 decimal place. We must label this answer. Population density must be labeled for the answer, and it's labeled as people per square mile. What that means is, if you were to go out in the middle of the United States and mark off a huge square, and that square had dimensions 1 mile by 1 mile. It's a square mile. On average, there's almost 80 people that live inside of every square mile in the United States. That's what population density means. Number 19. Lainey wants to calculate the height of the sculpture. So the sculpture is this lovely looking dolphin, which is not a fish. She places a mirror on the ground. Picture shows where the mirror is. So that when she looks into the mirror, she sees the top of the sculpture as shown. What is the height and feet of the sculpture? Let's assign this sculpture a variable. Typically, if it's a vertical distance I'm trying to find, I'm going to use y. And horizontal, I usually use x. So first we have to figure out, are these pictures in fact similar? Well, some assumptions you always make in word problems. People that are standing up assume they're vertical. That makes this 90 degrees. Also assume that the dolphin is vertical, so that's 90 degrees. Something that we have not discussed at this point, if you were to look into a mirror that's laying on the ground, the angle that your eyesight makes with the mirror and the angle that comes off of the mirror into the other direction, they're always the same, which means these two triangles are similar by the angle-angle similarity. So let me mark the corresponding parts. That's corresponding to this, and these two are corresponding. So now we just have to make a proportion. 4 is to y. Actually, when you make this, keep in mind you can make this in lots of ways. I like to have my variable on top. So let me say y is to 4 as 30 is to 3. Let's just double check to make sure we have relationships vertically and horizontally. What do y and 4 have in common? Corresponding. What do 30 and 3 have in common? Corresponding. What do 30 and y have in common? They're both on the triangle on the right. What do 3 and 4 have in common? They're both in the triangle on the left. Notice once again that when you make a true proportion, the diagonals have no relationship. What does 3 and y have in common? Nothing. What's 30 and 4 have in common? Also nothing. So to solve this equation, I could simplify the left. 30 over 3 is the same as 10. Then to get y by itself, I can multiply both sides by 4. 4 times 10 is 40. Y divided by 4 times 4 cancels. What is the height in feet of the sculpture? The sculpture is 30 feet tall. You would think with all the writing experience I had, my handwriting would be better. Whoa. But you'd be wrong. Almost finished. Number 20. Triangle ABC is dilated with a scale factor of k and a center of dilation at the origin to obtain A prime, B prime, C prime. Remember, this is the pre-image and this is the image. When you look at the picture, this is drawn to scale. The blue picture is the pre-image and the red picture is the image. Common sense tells us that k has to be a number that's bigger than 1 because the image got bigger. So remember that. If you get an answer and it's not bigger than 1, you know you did it backwards. So we have to take the original triangle, multiply all the sides by the same number to get the new triangle. The original is the image. The new triangle is the original is the pre-image. The new one is the image. So to do this, I can pick any two corresponding sides. Now, if we're lucky, we'll have something that's vertical or horizontal. So let's say that we pick this vertical side here, AB. So I need to take AB, its length, times some number k to get the image A prime, B prime. The length of AB is 1, 2, 3, 4. So that's 4 times k. The length of AB is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 times some number is 10. Divide both sides by 4. That reduces. K is 5 over 2. If you multiply the pre-image by 5 over 2, you will get the dimensions of the image. Last one. A 10-foot ladder and a 3-foot ladder are leaning against a house. Now the way this picture is drawn, this 10 scares me where it's written. I'm going to write it here and cross that off. 3-foot ladder, I'm going to write that here and cross that off. And if you still don't like that, if it's not clear, redraw both of these triangles. I'm going to redraw both these triangles. That is this triangle here. We have a height of 2.5, a 90 degree, and a 1 arc, and that's 3 feet is the hypotenuse. Then we have this large triangle here. It has a 90 degree angle as well, and a 1 arc. The length of that ladder is 10 feet. Let's finish reading the question. I got a little eager. The two ladders create angles of the same measure with the ground. That's this angle and this angle. The 3-foot ladder has a height of 2.5 feet against the house. That's this part here. Question, what is the height in feet of the 10-foot ladder against the house? So that's this y value. These two triangles are similar by the angle-angle similarity. So that means that this side corresponds to this side, and this side corresponds to this side. Therefore, if we make a proportion, y is to 2.5 as 10 is to 3. There are 8 different ways to make this proportion correct. Solving this, I'm going to multiply both sides by 2.5. On the left, 2.5's cancel and I get y equals. On the right, 10 times 2.5 is 25. So the exact answer is 25 over 3 feet. I should write this out in the sentence. The height is 25/3 feet. Done. Your quiz will be very similar to this review. Thank you very much. Have a good day.